Hello, families, and welcome to the Class 11 assignment follow-up. So you've had a job of work breeding flies and then breeding the offspring of those first breeds and then counting and sorting and sorting and counting. So let's enjoy that pay dirt, huh? Okay, so to remind you, we started out in class 6 with the ready experiment, right? You had the jars and there were 2 vials of food inside those jars along with different kinds of flies in each of those jars, right? One of the food vials was closed, one was open. Shock of shocks, only the open vial had eggs and larvae and pupa and new flies in it. And then in class 8, we started sorting and crossing flies. We found our virgin females and our males, and we put together all different kinds of crosses to see if we could, and in the process of knocking the flies out so we could sort them properly, we would put some of them in a cold shock and see if their babies were ultimately better cold adapted. They weren't, so it disproves Lamarck's hypothesis, but it gave us some really useful data in class 10 when we realized that certain traits um, led to more offspring than others. And if we projected that over time, we would see a very different population of flies, hence Darwin. And now we're going to um, see what Mendel has to offer us in terms of the particular traits that we see in those 2 generations of flies that we bred. So just to remind you, these are the crosses that we started for Lamarck, 5 different traits, um, and both male and female cross with each trait for a total of 25 crosses. So remember that Mendel had 3 laws of genetics. One was a law of dominance, where one trait completely masks the other. There's not really blending most of the time. The other was the law of segregation. Again, the traits don't blend, so you may not see a recessive trait in the first generation, but you will probably see it in the second generation. And the third was the law of independent assortment. So what does that mean? Um, so this is where we're looking at 2 different traits at the same time. So what the law of independent assortment looks like is something you can see with 2 different dice. And you'll see why I have 8-sided die instead of 6-sided die that you're probably used to, the cubes. So imagine you've got 2 8-sided die, um, and you want to see how often different combinations of numbers come up, right? So for each die, the blue and the red die, there's a 50% chance that you'll get an even number when you toss it, as the 8 is facing forward, and a 50% chance that an odd number will face forward, right? So the 50% chance that you get 2, 4, 6, or 8, and a 50% chance that you get a 1, 3, 5, or 7. And the same goes for the red dice. Now, when you toss both die at the same time over and over again, what that means is that roughly 25% of the time, you'll get an even blue die and an even red die. 25% of the time, you'll get an even blue die, but an odd red die. 25% of the time, you'll get an odd blue die and an even red die. And 25% of the time, you'll get an even blue die. And I'm sorry, I should have changed that. But you'll get both odd. I should have changed that. But in any case, blue even, blue even, red odd, blue odd, red even, and blue odd, red odd. Right? Sorry, I will change that slide. Now, what happens if instead of just looking for even or odd numbers, you so again, there's a 1-to-1 ratio, even to odd, right, for both die. So when you cross them together, you get a 1-to-1-to-1-to-1 ratio, right? Each uh, numerator is multiplied both, one ratio is multiplied by the numerator of the other ratio, and then again, that first ratio is multiplied by the denominator of the second ratio. You get both. Okay. So what happens instead of even and odds if we're tracking something like you get numbers 1 through 6 versus 7 through 8, right? So if you're looking to see how often your blue die comes up 1, 2, 3, 4, 5, or 6 versus how often it comes up 7 or 8, there's a roughly 75% chance that it'll be 1 through 6 and a 25% chance that it'll be 7 through 8. So a 3-to-1 ratio. And the same with the red die. So what happens if you cross these two together? If you're looking at these two traits, say 1 through 6 is dominant and 7 and 8 are recessive, all right? And you've got the blue dice trait and the red dice trait. What do you get? Wow. Now there is a 56.25% chance that you'll be 1 through 6 blue and 1 through 6 red. There's an 18.75% chance that you'll get 1 through 6 blue, but 7 or 8 red. There's also an 18.75 percent chance that you get 7 or 8 blue, but 1 through 6 red, and a 6.25% chance that you'll get 7 or 8 for both dice, right? So where did these numbers come from? Well, 56.25% is what you get when you multiply 75% times 75%. 18.75% is what you get when you multiply 75% by 25%, or because of the commutative property, sorry, I don't know why my thing is going crazy here, 25% multiplied by 75%. And 6.25% is what happens when you multiply 25% by 25%. So it's the same as multiplying a 3-to-1 ratio by a 3-to-1 ratio, right? You get a 9-to-3 to 3-to-1 ratio. In other words, the 9 comes from multiplying the 3 times the 3, and then you've got that next 3 in the 9-to-3 to 3-1 ratio. The blue 1 by the red 3, that second 3 in the 9-to-3 to 3-1 ratio is multiplying the red 1 by the blue 3, and then your 1 is 1 times 1, right? So Gregor Mendel knew that. So when he kept seeing ratios of 9-to-3 to 3-to-1, he recognized that those numbers were pretty special. That's why it pays to be good at math, or to get good at math, which he spent a lot of hard work and time doing, and man, did he hit pay dirt. So let's take a look at your crosses and see if we see those familiar numbers. And we'll start with the Antennapedia crosses, right? We took Antennapedia female virgins and crossed them with Antennapedia males, ebony males, eyeless males, vestigial males, and white-eyed males. And we also took Antennapedia males and crossed them with ebony virgins, eyeless virgins, vestigial virgins, sorry, virgin females, and white-eye virgin females. So what was the result? Well, this is what you probably got something like this in your spreadsheet that's included with your materials. Right? There's the first generation where everything has antennapedia. Um, and the one exception is that in addition to everything being antennapedia, if you cross an antennapedia, I don't know why that's a, yeah, sorry. If you cross an antennapedia, um, what is that, male with a white-eyed female, you also get everyone's antennapedia, but the males are also have white eyes, like 100% have antennapedia and white eyes. So that's weird. Now the ratios get a little different when you get into the second generation, but you saw that coming. Um, so let's distill this down just a little bit. Okay, so we've got our antennapedia, our ebony bodies, our eyeless eye shape, our vestigial wing shape, and our white eye color. So those are our parents. In the first generation, shock of shock, you breed antennapedia females and males, you get antennapedia kids. That shows you that your stock is true breeding. If you see anybody who doesn't have antennapedia in that stock, be concerned. Somebody got into that vial who shouldn't have been in there. That's okay. We can fix that. Okay. And again, should be the same in the second generation. So you breed antennapedia with ebony. They don't have ebony colored bodies. They're just kind of like, yellow brownish, I guess. But they do have antennapedia antennae sticking out of their heads. Okay. And in the second generation, you get, like for every roughly 6 kids that are antennapedia, sort of brown bodies, um, we call them wild types, which you would normally find in the wild. Um, there's one kid that doesn't have antennapedia and a wild type colored body. Um, and there's one kid that has, um, you know, ebony colored body and antennapedia, and, you know, 1 to 2 kids who don't have antennapedia but do have ebony. That doesn't really look like the numbers we'd expect. It's not really close to the 9 to 3 to 3 to 1. So that's weird. Okay, so let's look at eyeless. Again, first generation, everyone has pretty normal shaped eyes, but antennapedia. Okay. Second generation, we have, so what I got with all of my numbers is that regardless of whether antennapedia came from the mom or the dad, roughly for every 9 kids that had antennapedia and normal shaped eyes, there were 3 that had normal shaped eyes and normal antennae. There were 3 that had, um, sorry, so I think yeah, no, that's fine. You had 3 kids that had antennapedia and eyeless shaped eyes, and 1 kid who had eyeless shaped eyes but no antennapedia. Now, like I got way more than 16 fly this cross. I'm just distilling it down into its ratios. So that looks a lot more like something we'd expect, a roughly 9 to 3 to 3 to 1 ratio. Okay, so vestigial is the same sort of thing, right? When you cross vestigial with antennapedia, it didn't matter whether the antennapedia was coming from the mom or the dad. Um, you know, roughly for every 9 kids that had antennapedia and normal wings, there were 3 that had antennapedia and vestigial wings. There were 3 that had normal wings and no antennapedia, and there was 1 who had no antennapedia but vestigial wings. So again, that looks a lot more like what we might expect. Now, things get a little weird when we cross Antennapedia with white eyes. So if the mom has Antennapedia and the dad has white eyes, in the first generation, you'll get 100% Antennapedia red eyes. If the dad has Antennapedia and the mom has white eyes, you will see that everyone's got Antennapedia, but the sons also have all white eyes. All the girls will have red eyes, all the boys will have white eyes. Okay? And then um, in the second generation, if grandma had Antennapedia and grandpa had white eyes, the excuse me, I'm trying to find a good place to put my face. The all the females will have um, red eyes. Sorry, all the females will have red eyes, and 75% of them will have Antennapedia as well. But all the males look a little different, right? You'll have Antennapedia red eyes, Antennapedia white eyes, no Antennapedia red eyes, no Antennapedia white eyes in a 3:3 to 1:1 ratio. Now, if grandpa had Antennapedia and grandma had white eyes, then in the second generation, it doesn't really matter if you're male or female. You know, for every 3 red-eyed Antennapedia, you'll have 3 white-eyed Antennapedia, 1 red-eyed non-Antennapedia, and 1 white-eyed non-Antennapedia. And again, I had a lot more than uh, 8 flies in this cross. I'm just kind of distilling it down to their ratios. Okay, so let's see. To summarize, the fact that in the first generation we're going to ignore white-eyed crosses for now because they're a little weird. So let's just stick with the other 4 crosses, or I should say 7 crosses. So what we see consistently is the first generation, they're all Antennapedia and you know, wild type, everything else. So that tells us that Antennapedia is dominant. And in the second generation, we see that aside from Antennapedia breeding with itself, with respect to eyeless and vestigial, we see pretty close to those 9:3 to 3:1 ratios. That's telling us that Antennapedia and eyeless sort independently, and Antennapedia and vestigial sort independently. They're 2 separate dice, right? Whether you throw the dice for Antennapedia and you get a 1 has no effect on whether you throw the dice on vestigial or eyeless and get a 7. Um, they're sorting independently. Now, it's kind of a question mark when we come to ebony. And to be honest, we're not going to figure out the answer to that this class. So hold on to that mystery because that we're going to have to delve a little deeper with respect to that. Now, I just want to summarize the rest of the crosses here. So again, ebony times ebony gives you 100% ebony, at least it should, unless somebody got in there who wasn't supposed to be in there. It happens. Don't get too upset if that does happen. You know, eyeless and eyeless, 100%. These should all be true breeding traits. And in general, you see those roughly 9:3 to 3:1 ratios. They're off by 1, you know what I mean? Especially if it's 9 or 8 or 10, right? It's close enough. But there are 2 big exceptions, right? We did a lot of crosses, and we see two big exceptions to what we expect. The first is that Antennapedia and Ebony, only those two traits in a combination. We do not see that 9 to 3 to 3 to 1 ratio. So we have a hint that maybe we're not throwing two separate dice, right? That we're not seeing that like Antennapedia only goes with the wild type colored body and Ebony only goes with normal shaped antennae. It's not that they're, completely separate, but they also aren't sorting independently like two separate dice. So that's weird. The other thing that we notice has to do with any white-eyed cross. What comes out really depends on whether it was grandma or grandpa who who had the white eyes, right? If grandpa had the white eyes, the females were always in a 3 to 1 ratio. That is, they 3 to 1 red eyes. So it kind of seems like white eyes is recessive and that red eyes are dominant. But the males are different too, right? You actually get four different combinations of traits in a 3 to 3 to 1 to 1 ratio. That's not the same as the 9 to 3 to 3 to 1 ratio. Now, if grandma had the white eyes, it didn't really matter if the grandchildren were male or female. There were four different combinations of traits, but they weren't 9 to 3 to 3 to 1. Once again, they're 3 to 3 to 1 to 1. So again, that's weird. We will get to the bottom of these two mysteries, but not today. So let me know if you got similar ratios with your crosses or if you got something vastly different. I will be very, very curious. In the meantime, let's summarize what I got with my crosses. Antennapedia is dominant. Ebony, eyeless, vestigial, and white eyes are recessive. And we see that because in the first generation of an ebony crossed with anything that wasn't ebony, you didn't see ebony flies. You saw sort of the wild type brown colored bodies. Same with eyeless, right? In the first generation, you didn't see any wonky shaped eyes. You saw pretty round eyes. Vestigial, in that first generation, you didn't see any wonky wings. You saw the normal flying wings. The white eyes were a little different, but you tended to see more red eyes than white eyes, generally speaking. Okay. All traits demonstrate independent assortment, again, that 9 to 3 to 3 to 1 ratio, except Antennapedia and Ebony, sorry, I misspelled ebony. Only that cross, not any other Antennapedia cross and not any other ebony cross. And white eyes with anything else. So like I said, those are mysteries we are going to solve in the coming classes. So stay tuned. And in the meantime, again, congratulate yourselves on a job of work. This is massive, but you really needed all those crosses to demonstrate Mendel's 3 laws of genetics. You did. And I'm so proud of you, and you should be too. So congratulations.